Hi everybody, I hope you are doing well. This is Unit 2, Lesson 4, Approximate Values of Irrational Numbers. So if you remember, irrational numbers, we can't write them perfectly and exactly because they go on forever without any pattern. Okay, pi is a great example of that. Just some quick key terms, all right, that these are listed in your lesson and stuff, but this symbol here is called a radical, all right, and it's the symbol we use for when you need to find a square root, okay? And a square root is when you, like you have a number that you multiplied by itself to get to a new number, right? Also known as like applying an exponent, right? And you're doing the opposite of that. That's what that square root is. Okay, you're finding the root of the square that you did. And we'll talk more about that, especially with these perfect squares. And this term, I just thought it was kind of cool, radicand. All right, a radicand is the number under the radical. But I just like that name, or that term. Okay, so here's some examples of perfect squares. Okay, so the square, remember this means square root. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2 because 2 times 2 gets us to 4. Okay? So that's why those are opposite. Remember we can say like 2 times 2, which is 2 squared, which gets us back to that 4. All right? So the square root of 9 is 3. The square root of 16 is 4. And so on. All right? These are the first few perfect squares, and they're called perfect squares because they have whole numbers as their answer. All right? So that's where those are coming from. Right? They're so much easier to work with. Let's go through some examples. I've got 3 for you today. That seems to be my favorite number of problems to complete. So here's number 1. If you don't have a piece of paper or a notebook ready, go ahead and pause this and get it because these come directly from your practice, which is on page 13, and your quick check, which is on page 14. Okay? So, number 1. Using a number line, what whole number and rational number to the nearest half is the square root of 10 between? Well, gosh, that's a little crazy, right? But one thing we can do is we can think, okay, the square root of 10, that's going to fall somewhere in between the square root of 9 and the square root of 16, right? So let's start by setting that up. Oh, man, that was not a very straight line, was it? Let's start setting that up, that even if I have these here, right? So the square root of 9, which is equal to 3, and the square root of 16, which is equal to 4. Okay? Well, 10 is way closer to 9 than it is to 16, right? So I could put that like right here. It's going to be somewhere right around there. Well, the wording in the question says what whole number, and rational number to the nearest half is the square root of 10 between. Well, if we're talking about halves, and we're right in between 3 and 4, right in between that, or half of that, is going to be 3.5, or 3.5, 3 5/10. Okay? So those are our answers. 3, the square root of 10 is right in between 3 and 3.5. 3 and 3.5. Okay? So hopefully that helps seeing it done. Okay? Number 2, using rational approximations. Doesn't that sound fancy? Using rational approximations, what is an inequality statement comparing pi and the square root of 8? Okay? So, first off, I want to go ahead, I'm going to set up another number line. Okay? And I'm going to think to myself, okay, square root of 8. Well, the two perfect squares around that are going to be the square root of 4 and the square root of 9, right? You can look at that chart or that number line that I set up on the previous page. You can either rewind the video or hopefully you wrote it down. The square root of 4 we know is equal to 2. The square root of 9 we know is equal to 3. Okay? So let's see here. Well, knowing pi, you've probably heard that before, where we know that pi is equal to about 3.14. So that's like over here-ish on my number line. Well, the square root of 8, that's going to be right here, right? The square root of 8, square root of 9. So that's somewhere in here. And the nice thing about this one, I don't even need to like really approximate it. I don't need to give an exact number right here. I just need to set up an inequality statement. Inequality. We know that the square root of square root of 8 is not equal to, or it's unequal to pi. Right? So that's why we can't put an equal sign. We're going to use an inequality sign. So we could say the square root of 8, we're comparing them, right? The square root of 8 we know is less than pi. Okay? One way that I've always thought about making sure that the inequality symbol is facing the right way. Some people like to think of it as a mouth, right? It eats the bigger number. You can also think the bigger number gets 2 dots, the smaller number gets 1 dot, and then you connect them. Either way, but this way too, our mouth is set up towards pi. You could also write it the opposite way. You could say pi is greater than the square root of 8. Okay? Depending on how your problem is set up on the computer, you might need either one of those. Okay? Number 3 is taken from your quick check. So, write it down. Giving you answers. Using a number line, what is the approximate value of the square root of 19? Okay? So, using a number line, let's see here. Set up our number line. It's just such a good visual, right? So, the two perfect squares that the square root of 19 is between is going to be the square root of 16 and the square root of 25. Those are the perfect ones because the square root of 16 is 4, square root of 25 is 5. Well, let's see. We could have 17, 8. It's going to be closer over here, right? So somewhere right around here. All right. Again, it's approximate, right? We're approximating. Now, in the problem, you're given 4 different choices. Okay? Right? 19 is closer to 16. In the problem, you're given 4 options. I'm going to read them off. Let's see. We're given 4.7, 4.3, 4.5, and 4.1. Okay? Well, I want you to notice something, right? We're between 4 and 5, so it makes sense that they all start with a 4. But if I were to make another line right here, that would represent 4.5, right? It's halfway between 4 and 5. So we need to kind of use our number sense and logical reasoning to realize, okay, 4.5, that might work. It's like fairly close. But look at this, 4.7, that's going to be way over here. That's going to be further away. So that's going to be less accurate. So 4.7 right away, just because of how high that's going to be, that doesn't make sense. Okay? Also 4.1, maybe, but again, it's still like going to be a little bit further away. That's going to be much closer to over here than even 4.3. So the most logical 2 choices are going to be 4.3 and 4.5. But to check our work, and to make sure we have the one that is truly the closest, we should multiply these, right? In order to get from 4 to 16, we got to do 4 times 4 equals 16. 5 times 5 equals 25. So what we should do is we should see, okay, well, what's 4.3 times 4.3? And then do 4.5 times 4.5 and see which one of those answers is closest to 19. All right, so it's going to take a second, but we want to get that accurate answer, not only because it's worth credit on our quick check, but because it's the best practice for us as well in understanding the number values. So I'm going to go ahead and do that now. We've got 4.3 times 4.3. I'll set this one up too. 4.5 times 4.5. Okay, remember when you are multiplying with decimals, you don't need to worry about the decimal until the very end. All right? So 3 times 3 gets me to 9. 3 times 4 is 12. I'm going to annex my 0 so I can start multiplying with my 4. 4 times 3 is 12. So drop my 2, carry my 1. 4 times 4 is 16. Plus 1 is 17. And then we add them together. 9 plus 0 is 9. 2 plus 2 is 4. 1 plus 7 is 8. And bring my 1 down. Now I need to worry about my decimal. I have 2 numbers behind my decimal in my in my problem. So I need 2 numbers behind the decimal in my answer. All right, look at that. That's pretty close to 19. Okay, let's see what happens with this one. Is it going to be even closer to 19 or further away? So 5 times 5, 25. 5 times 4 is 20. Plus 2 is 22. Annex my 0. 4 times 5 is 20. Drop my 0. Carry my 2. 4 times 4 is 16. Plus 2 is 18. Add them up. 5 plus 0 is 5. 2 plus 0 is 2. 2 plus 8 is 10. Drop my 0. Carry my 1. And 1 plus 1 is 2. Once again, I have 2 numbers behind the decimal in my problem, so I need 2 numbers behind my decimal in my answer, giving me 20.25. 20 and 25 fifths. So looking at those 2 answers, right? Even if you can think of it in terms of money or however you want to think of it, but this one is only 51 hundredths away from 19. This one is 1 and 25 hundredths. So this one is further away, meaning that 4.3 is a much closer answer. Okay? So I hope that makes sense. Good luck on your quick check and call me if you need help.